Hello everyone, we are presenting here metals and non-metals for class 10th part 1st, brought to you by www.tranquilscience.blogspot.com. Today we are talking about metals and non-metals. So firstly, what is an element? An element is a pure substance which is made up of the same type of atoms. Nearly 118 elements have been known at present. These elements can be classified into two major categories as a metal and non-metals, as they have opposite characteristics. Also, there is another classification as a metalloid. They are also called as a semi-metals or borderline because they show both properties, metals property also and non-metals property also. Now let's discuss the characteristic of both metals and non-metals. Now, what are the metals? The elements which are electropositive, that is, form positive ions by losing electrons, are called metals. They have 1, 2 or 3 electrons in their outermost shell. For example, sodium. Sodium having 11 electrons and its electronic configuration is 281. So it loses 1 electron to form Na plus ion and gets stability. Now, on the other hand, non-metals are the electronegative elements as they gain electrons to achieve stability. For example, chlorine has 17 electrons and electronic configuration is 287, which needs 1 electron for stability, so gains 1 electron and form chlorine ion. So non-metals have 4 to 8 electrons in their valence shell. The easiest way of categorizing the elements as a metal and non-metal is by comparing their physical properties or chemical properties. Let's discuss their physical property. The first physical property of metals which we are going to discuss is hardness. So, take small pieces of Fe or copper. If you try to cut even a thin rod into two pieces, it will not be easier for you. You know why? Because metals are the crystalline solids which contain close packing of atoms with each other. This atomic bonding in metals is called the metallic bonding. And due to this strong metallic bonding, metals are very hard, and this hardness varies from the metal to non-metal. But there are certain exceptions also, as for example sodium and magnesium, which are exceptionally soft metals and can be cut with a knife. Now if we talk about non-metals hardness physical characteristics, non-metals exist in all three states of matter. Only solids are expected to be hard, although they are softer than the metals. Example, graphite, one allotropic form of a carbon, or sulfur or phosphorus. They all are soft. However, exceptionally diamond. Diamond is another allotrope of carbon, which is one of the hardest known substance. Now let's discuss another physical property of a metal, that is metallic luster. Luster. Luster means shine or brightness. Take some metals like copper, aluminium, Au, magnesium, clean their surface with a sandpaper. You will find them much more shinier and lustrous. Actually, metals have 1, 2 or 3 loosely held electrons in their valence shell When the light falls on the metallic surface, metals absorb photons and electrons get excited and start vibrating, which in turn releases light energy, so metal surface shines. You daily come across a variety of shiny metals. Example, gold, which is yellow and having yellow lustres. Copper, copper has reddish brown luster. Aluminium, aluminium which is bright white in color. If we talk about non-metals, non-metals lustrous physical property. So the non-metals are non-lustrous in nature and can't be polished. But the biggest question is why? This is because they don't have loosely attached electron in their valence shell, which are responsible for the luster. However, diamond, iodine, graphite are some exceptions. They show lustrous property. Now the third property which we are going to study is a melting and boiling point. Have you ever seen metals like copper, aluminium, gold, silver, etc. melting in extreme summers? Obviously not, because these metals have a strong force of attraction between the constituent atoms. But exceptionally, gallium metal having a low melting point. You know an interesting fact that the gallium melts even in your hands just because of its unusual low melting point. In contrast, nonmetals have lower melting points and a boiling point, as they don't have close packing of atoms, so release electrons more easily. But nonmetals like H2, O2, N2, argon, etc. are the gases at the room temperature and have very low melting point and a boiling point. But there are some nonmetals like silicon, carbon, they are solid at room temperature. Let's discuss another physical property, that is the thermal conductivity. But the biggest question is that have you ever analyzed this thermal conductivity and what is this thermal conductivity? Yes, I think you have analyzed this a number of times in your daily life. Like when you heat one end of any metallic rod by burner and after few minutes what you observe. So after few minutes when you touch the other end of the rod it becomes hot too, and this way we can illustrate that metals are the good conductor of heat, and this is the thermal conductivity. So there are some metals which are very good conductor of heat, that are the silver Ag and copper Cu, but there are some exceptions also like lead Pb and mercury Hg, which are the bad conductor of heat. But talking about the non-metals, due to unavailability of the free electrons, they are the poor conductors of heat, except only graphite, as you can see here. It conducts heat from one end to another end on heating with a burner. So we can conclude that it is a good conductor of heat. Another physical property we are going to discuss is the electrical conductivity. As we have already discussed that the metals are the good conductor of heat, but do they conduct electricity? You must have seen in our homes all the electric wires are coated with PVC or a rubber-like material. But why? Are metals really good conductor of electricity? Let's find out through an activity with an iron nail. Firstly, connect it with the battery through a bulb. What would you find then? A bulb starts to glow. It's a miracle. Not really. Actually, what happened when electric current passes through the iron nail, iron being metal, conduct electricity. So it's clear due to availability of free electrons, metals are good conductor of electricity, while non-metals are the poor conductor of electricity due to the absence of free electrons. Let's discuss the sixth property, malleability and ductility. Have you ever observed in your lunch time your food is wrapped in a aluminium foil, and when you go to confectionery shops the items are covered with the aluminium foil or silver? But have you ever thought how these foils are made? Actually, these metal sheets formed by beating them with a heavy device or hammer, and this property is known as a malleability. Similarly, you must have seen copper or aluminium wiring at your homes. So that means metals can also be drawn into thin wires, so they are ductile in nature, and this property is known as a ductility. In contrast, non-metals have weak attractive force, so can't be beaten into thin sheets. For example, if sulfur is taken and beaten with a hammer, it would be broken into pieces, so it is non-malleable. Similar to sulfur, other non-metals are also non-malleable, and they are also non-ductile. But there are some exceptions. Diamond. Only diamonds show ductile nature, as it is quite hard. Due to this hardness characteristic, we can see diamond. Diamond is used to make beautiful jewelry. The next property which we are going to study is sonority. When any metal strikes a hard surface, produces a particular sound. The property is called a sonority. Ringing bells have their own charms, but did you ever realize where these sounds come from, or what happens when a metal strikes a hard surface? Whether it is a bell ringing in a temple, or maybe an alarm clock or your favorite school bell, they originate when the metal strikes any hard surface, and this property of metal is called a sonority, and these metals are said to be sonorous. But if we talk about non-metals, they are non-sonorous. No such sound produced by them on striking any hard surfaces. If you appreciate our efforts, please share with others and comment us. For more videos and science related stuff, log into our website www.tranquilscience.blogspot.com. Thanks.